6 is on what we call binomial experiments. You might also hear these called Bernoulli trials because that's Bernoulli. He's a mathematician. There were several Bernoullis, but that's the one that came up with the Bernoulli experiments. So like I said, it's described by just two outcomes, so winning, losing, heads, tails, boys, girls, etc. So number 1, so make a tree to find the probability that you get exactly 3 heads in 4 coin flips. So hopefully you guys have started that tree. And so for the first coin flip, you can have heads or tails. And the second one, you also get heads or tails. So right now, with just 2 coin flips, you could have heads, 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 tails, tails, heads, tails, tails. And we go one more time. So, oh, it is 4 coin flips, isn't it? Man, rough. I should have given myself more room, shouldn't I? So we're going to have heads, tails, heads, tails, heads, tails. So you can see that once you have, 4 of these coin flips, it gets a little annoying. It's a lot of things to write, isn't it? So if we're talking about exactly 3 heads, we have several routes that do this. So we have the route that goes heads, 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 tails. We have the route that goes heads, tails, or heads, heads, tails, heads. We have heads, tails, heads, heads. We have tails, heads, heads, heads. Do we have any more that have exactly 3 heads? No. So we end up getting 4 out of a total of how many possibilities? How many branches do I have in the end? 16. Do you guys see it? Because it's going to be 2 times 2 times 2 times 2. So our answer is 1/4. Okay, so if I asked you to do the same thing, and I said, find the probability that you get 3 heads in exactly 3 heads in 10 coin flips. Do we want to draw a tree? No, that would take a lot. That would take a lot of time to draw a tree with 2 to the 10th of those branches. Okay, so there has to be an easier way. So we use what's called the binomial experiment, or Bernoulli trials, to do this. So it says in a binomial experiment, P, so the probability of R successes in N trials, ends up being, we take the combination of N, choose R, and we multiply by the probability of success, R times, and failure, N minus R times. Okay. So it's a complicated formula, right? And I'm sure all of you guys are like, oh my gosh, do I have to memorize this? This is complicated. So we want to talk about where this comes from. Okay, so the first thing, going back to this tree, is if I had 4 coin flips and I want to get exactly 3 heads, then how many tails do I have to have? 1. Does this make sense? So basically what we're doing is we're saying we have 4 different positions and we need to choose 3 places to have heads. So I could have heads, heads, heads like this. I could have heads, heads, heads like that. I could name all those different ways. Well, what is that we're doing? So relate it back to this probability chapter. We have 4 positions and we're selecting 3 places to put heads and we're selecting 1 place to put tails. What is that called? Close. So it's a permutation. It's called a combination, right? So it's saying, how many ways can I choose these 3 positions to mark them as heads? Okay? And then the other one's going to automatically be a tail. Well, I did most of those right now. So I could also have heads, 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 tails, and I could have tails, heads, heads, heads. I can actually write those out. Do we see that? And what that is 4, choose 3. Or what else could I write it as? 4, choose 1. Do you guys remember that concept? So if I have a really cool club and 4 people want to be in my really cool club, it's a math club, clearly, and I only have 3 spots, then the number of ways to select those 3 people to be in my cool club is the same as saying, oh, that one person, you can't be in my cool math club. Does this make sense? So it's like saying the number of ways to pick those places for 3 heads is the same as picking the 1 place to put the tail. Well, tail here, 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 and here, right? Does that make sense? All right, so that's what we were doing with the branches. Do you guys see? So with my red lines here, I had heads, 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 tails. I had heads, heads, tails, heads. I had heads, tails, heads, heads, and I had tails, heads, heads, heads. So that's coming up with the number of branches that have that probability. Now, when we did probability trees, we also put numbers on here. So I said, oh, it's half that I go here, it's half that I go here, and I had all these probabilities on there. Okay, so now I multiply by the 1/2, and how many times do I have heads? I had it 3 times, so it's like writing 1/2 to the 3, and then I have the 1/2 to the 1. Now in this example, it's not a big deal because our probabilities were both 1/2, so I could have easily just done 1/2 to the 4. What's 1/2 to the 4? 1/16. That's giving me my denominator. It's telling me how many total routes I have, okay? But it's not always like that. So the probability of winning games and losing games is not always like 1/2, right? So that's what we have here. So it says Kyle has a probability of 0.3 of getting a hit each time he's at bat. What's the probability that he will get exactly 1 hit in 4 times at bat? Kyle, do you play baseball?
No.
No. I didn't think so, but you never know. All right, so let's say that we have a hit and a no-hit. So hit, no-hit, I guess I'll write. And then I have a hit and I have a no-hit. We probably don't want to continue this table, right, or this chart, because it's going to take us a while. But that's how it would look. So we're finding the probability that he gets 1 hit in 4 times at bat. So how many ways can I select the spaces, right? If I put those spaces out and I said, okay, I could have hit, no hit, 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 right? Right, 1 hit, 3 no hits. What do I put for my combination? I do combination 4, choose 1. I'm choosing the 1 spot for that hit. Okay, well, what's the probability of success? What's the probability of getting that hit? For each time he's at bat, it's a probability of what? 0.3. And how many times do I have 0.3? 1 time. So what this is saying is on this table I have 0.3, and then my probability of not getting a hit is what number? 0.7. It's the rest of the probability. So it means if I took this route where I did, oops, I guess I want no hit, right? Because I want 1. So if I took the route where I had 3 no hits, I have 0.7 listed 3 times, and I have 0.3 listed 1 time. Do we see this on the chart, on the t-table? Not t-table, what am I talking about? On the tree. So I have 0.7 how many times? 3 times. So we're just listing how many times we have each thing. So the probability of us getting hit was 0.3. We had that once. The probability of Kyle missing was 0.7, and that happened 3 times. And then we put it all together. So we now find this number. So you can do the combination of 4, choose 1. Do we know what 4, choose 1 is? It's 4. Because you're saying how many ways can I pick 1 no hit, or 1 hit, I guess, in 4 slots. And I have my 0.3, and then I have my 0.7 to the 3. So Gloria, 0.343, thank you. And then we're going to multiply these all together. So take your 4 times 0.3 times 0.343, and we get our final answer of what? 0.4116. That's our probability. It's like saying if you had 1 route that had hit, and then you had 3 routes that had no hit, the 3 was here, and the 1 was here. So the probability of getting a hit was 0.3, and the probability of not getting a hit was 0.7. So you have that 0.7 3 times.
So for the R and the N, what numbers are related to the R and the N?
Okay, so this is the total. This is the number of successes, depending on what you call a success. In this case, it was hitting that baseball. P is the probability of success. And Q is the probability of failure. So Q will always be 1 minus P. Does that make sense? So sometimes you'll see the formula with 1 minus P written in there. Okay, so let's try another one. These are weird at first. So it says each question of an 8-question multiple choice test has 5 possible responses, only 1 of which is correct. Find the probability of getting the results below by answering every question randomly. So the first one, exactly 5 questions correct. So we have 8 questions. We don't want to do a tree with 8 possibilities, right? With 8 stems, I guess. So getting exactly 5 questions right is going to be, we have 8 blanks, and we're going to find the number of ways to fill 5 of them with correct and 3 of them with wrong. So I'm going to do 8, choose 5, or I could have done 8, choose 3. It doesn't matter. Now, if there are 5 possible responses, what's the probability of getting it right? 1/5. How many of those correct ones do we have? Close. We said we get 5 right, correct? You see, we're finding the probability of getting 5 right, so we do 5. And then what's the probability of getting the answer wrong? 4 what? 4 out of 5. And then how many do I get wrong? 3. It has to be the rest of those numbers. So we find that answer. So we multiply it all out. So we do C, 8, choose 5, or we could do 8, choose 3. I'll let you use your calculator. We did learn a trick for that, though. So remember, if you're trying to do 8, choose 5, we do 8 first, we go to math, we go over to probability, we do NCR, and we hit 5. So 8, NCR 5, so we have that, 56. And then we're going to multiply by 1/5, so I'm going to put it in parentheses, and raise it to the 5. And then I'm going to multiply by 4/5, and I'm going to raise it to the 3. So when you do, you get the answer of 0.00917504. So on this homework, typically I will say, like, round to 3 decimals. I typically would just show all those decimal places, or at least 4. Okay, so if you want to do 0.0092, that's fine, but I'm just going to do 0.00917504. 0.009, what was it? 1.
750.
Thank you. Okay, so what does that represent? It represents a probability of like 0.9% of getting 5 right. All right, so the next one. So exactly 6 questions right. Well, it's the same process, but now we're going to do 8, choose 6, or you could do 8, choose 2. We have 1/5 to the 6th, and we have 4/5 to the 2. Do you think it's going to be more or less probability? Probably less, right? So we're going to do 8, math, NCR, 2. Oops, I don't know why I did 5 there. Or I could do 8, NCR, 6. It doesn't matter. Both of them are the same. So see, if you did 2 or 6, we get 28 for both of them. All right, then we multiply by 1/5, or you could do 0.2 if you want. Raised to the 6 times 4/5 raised to the 2. So we get 0.00114688. And that's our probability. Okay, does this make sense? Are we seeing some patterns here? Do you notice something about these two numbers? What do they add to be? 8, which was our number of questions. What about these two numbers? What do they add to be? 1, because it's talking about probability. So there's some patterns to it. All right, next one. So 3 or fewer questions correct. So this one's kind of annoying, right? Because if we're doing 3 or fewer questions correct, then we're doing the probability of getting 3 questions right, the probability of getting 2 questions right, the probability of getting 1 question right, and the probability of getting 0 questions right. Not very fun, is it? So we have to find all of those. Okay, so let's start out the pattern. So the first one is going to be 8, choose 3. We have 1/5 to the 3 and 4/5 to the 5, right? So getting 3 correct, the 1/5 is going to be raised to the 3, the 4/5 is going to be to the 5. And then the next one, we're going to have 8, choose 2, and we're going to do 1/5 to the 2, 4/5 to the what? And then we continue that pattern. So if you are good with your calculator, it's going to save you some time. So here's the way that I recommend that you do this. We're going to set it up kind of all together. So for this first one, the 8 choose 3 number, I'm going to do a parenthesis. So try it along with me if you have your calculator. I'm going to do 8 math PRB NCR3, and then I'm going to do times 1/5 raised to the 3, and then I'm going to do times 4/5, or you could do 0.8 raised to the 5. Okay, and I'm going to hit enter, and I'm going to get that number. Okay, so I get 0.14680064. All right. Now, some of your calculators allow you to go back up. You can hit the arrow up button, and you can grab that last thing that you put in. So you can grab this whole equation and hit enter, and it'll come down here. But some of your calculators don't let you do that. But they do, kind of. You just can't do the arrow up. So if that's the case, then you do second entry. Do you guys see entry? It's where the enter button is. It pulls up the last thing that you did. And now what numbers are we going to edit? Well, now we need 8 choose 2, 1/5 to the 2, 4/5 to the 6. Does this make sense? We're just changing those numbers. So I get 0.293600128. And then I do it again, so I do a second enter, and now I'm replacing it with 1. And I have 1/5 to the 1, and 4/5 to the 7. So I get 0.33554432. And then we have the last one. So now we have 8 choose 0, which is not 0, so don't think the whole thing's going to go away. 1/5 to the 0, and then 4/5 to the 8. So we get 0.167777216. And then we add them together. Okay, kind of time consuming, isn't it? Okay, so I'm going to do 0.1468004 added to point, anybody have it? Yep, so 0.9437 something. So we'll just do 4 at the end. 0.9437. Okay, perfect. Does this make sense? You guys get it? Okay, so if it says 6 or more questions correct, now we're doing the probability of 6 plus the probability of 7 plus the probability of 8. So that one just has 3. So do we understand that? Yes, just has 3. Do we understand how to do that? Now do you like what it says below? How to do difficult problems on the calculator. So there is a way that we can use our calculator to help us. Okay, so what we're going to do, man, I always forget this. I have to think about it each year. Okay, so we're going to do second, and do you guys see distribution? It's above vars. Vars stands for variables, so it's this button right here. So do second, and then distribution. And we're going to go down, and we're going to do Binomial Pdf first. Okay, so when we do a Binomial Pdf, that's finding it for a single one of those numbers. So if I wanted the probability for, let's do this number, the probability of getting 3 correct, then it's going to be NPR. So NPR, National Public Radio. Yeah. It might say N equals P equals R equals.
This is trials P X value pace.
Okay, that's fine. So it might say trials. Do you guys have that? Trials, what is it? Trials P?
Trials P X value and pace.
Okay, so we're going to do the same thing. So on mine, so Binomial PDF, I'm doing NPR, so the number of trials. How many trials did I have? So how many questions on the test? 8. And then I do comma. And then what's the probability of success? So what's the probability of getting the question right? 1 out of 5. And then what's the probability of, or NPR, so then what's the number that we're going to get right out of those 8? So I said we'll try the 3 number first, and then hit enter. Do we see this number here? Did the calculator just save your life? Are you excited about this? Can you guys see it? It's hard to see the green. So 8, so number of trials, probability of success for each one, number I want right, I get this number, which is the same as this. So I could do that for all those numbers. So I could do second enter, and I could put in 8, probability that I get it correct is 1/5, and then I want 4 right, or I guess it was 2 right was the next number. And then that gives the next number, 29360,128. Do we see it? And you can find all those numbers and you can add them together. But there's also, if you look under your distribution, there's something that says Binomial Cdf. So Binomial Cdf stands for cumulative. So it's saying find the probability of 0, 1, 2, 3, all the way up to what number you want. So in this case, that's a CDF. So the probability question that we had said find the probability that you get 3 or fewer correct. So we want to find the probability of 0, 1, 2, 3, all the way up to 3. Does this make sense? So what we do in this case is still NPR. So we would do 8, comma, 1/5, comma, and then we'd go up to 3. So that stands for the cumulative probabilities up to 3. And look what number we get, 0.9437. So do we like our calculators? It's a magical tool, isn't it? All right, so if you guys have the different setup, if you guys have the one that says trials, P, and X value, it's basically the same, okay? That's still NPR. So trials is the number of trials you have. So in this case, it was 8. Your P value was the number you want to get correct. So 3, or not 3, sorry, P is probability. So P is 1/5, and then our R value, or X value, I think is what it says on your screen, ends up being the number you want to get correct, so 3. So you can do this with your Binomial PDF, and you'll get this number right here. But if you do Binomial CDF, you'll get this number right here. Do you guys understand the difference? So C stands for cumulative, adding them together. Caitlin, do you have a question? How do you what? How do you put the X value in for cumulative? What does your cumulative tell you? Did you do Binomial CDF? Do you guys see it on your screen? So mine is different. So tell me what yours says on the screen. So do distribution, go down to Binomial CDF, and tell me what yours says. Does it still say trials, P? Yeah, so the X value is just up to 3. So you're putting in 3. Does that make sense? It's saying find the cumulative sum of all of those things up to 3. So still put in 3, and you'll get that final answer, the 0.9437. Thank you, Becca.
Why are we still doing 1/5?
1/5 is the probability of getting each answer correct. So let's do this one. So if it says 6 or more questions correct, well, you could find 6, you could find 7, you can find 8, but let's use the complement. So who can tell me what a complement is? Do you guys remember what a complement is? Not, oh, you're so good at math. Oh, you look so nice today. Not that kind of compliment. So in math class, the complement is the rest of the probability. So we talked about that when we were talking about cards. If I said, what's the probability of not getting a king? Well, we find the probability of getting a king, which was 4 out of 52, and then we subtract it from 1. Does this make sense? So let's use the complement to help us here. So if I'm getting 6 or more questions correct, what's the rest of the probability? What's the complement of that, Karen? So Binomial CDF up to what? Up to 5. Yes, that's exactly right. Do you guys see what she's saying? So we could do 1 minus the Binomial CDF, the cumulative sum, up to 5. So the number of trials was 8, our probability is 1/5, and we're going to go up to R equals 5. Because the cumulative sum is starting at 0. So it's going to find the sum of the probability of 0, 1, 2, 3, 4, and 5. So what's the rest of it? It's the 6, 7, and 8. Okay, so we go in here, and I do second distribution. I go down to my Binomial Cdf, or like I said, you could do each one individually if you want. You could just do 6, 7, and 8. So we're going to do 8, comma, 1/5, which is 0.2, and then 5. That's going to be the probability of getting 0 questions right, 1 question right, 2 questions right, 3, 4, or 5. And then we do 1 minus that answer. So we get 0.00123. Easy? So you can use this on your homework. You can use the calculator method. You just have to know how to use it, right? Okay, so let's try these ones. So it says each question of a 15-question multiple choice has 4 possible responses. So what's the probability of getting each one right now? 1/4, not 1/5. Only one of which is correct. Find the probability of getting the results below by answering every question randomly. So the probability of getting exactly 12 questions correct is going to be C, 15, choose 12. We're choosing the 12 we're getting correct. We're going to multiply by 1/4. How many times will we have the 1/4 for our branches? We'll have 15 total branches, but how many of them will have 1/4 marked on them? We'll have 12. Eric, open your eyes. And then we're going to have 3/4 to the 3. Do we see how that's set up? So we could do that without using the Binomial Pdf, Binomial Cdf. We could get that. But if we use this button, it's much faster. So we're going to do math, or we're going to do second distribution. Do I want a CDF or a PDF? PDF. We just want that one piece, right? And we're going to do, we have 15 trials. Our probability of getting each one right is 0.25 or 1/4. And we want to get how many correct? 12. It's very, very tiny. It's scientific notation. So it's 1.144 times 10 to the negative 5th. Which makes sense. Of getting the probability of getting exactly 12 right on the multiple choice. That's kind of weird, right? So 7 or fewer questions correct. Well, that means we want the probability of 0 right, the probability of 1 right, the probability of 2 right, all the way up to 7. So that's a Binomial Cdf. So we have the cumulative sum. So now we do our second distribution. We go down to Binomial Cdf. We had 15 trials. Our probability of success for each one was 0.25, and we want to find the sum up to what number? 7. Yep. And that's 0.9827. And then 10 or more questions correct. So do we want to do 10, 11, 12, 13, 14, and 15? That's 6 different probabilities and add those together? That's one of the 1 minus ones, right? So what's the complement? Yeah, it's going to be the probability of 0, 1, all the way up to 9, right? So we're going to find that. That's the CDF. So we're going to do Binomial Cdf, and we have our 15, 0.25 still, and we want to go up to 9. So 0.999205051. And we do 1 minus that answer. So we get 7.949 times 10 to the negative 4th. And that's our answer. Okay, does this all make sense? Do you guys get it? It's all related to the tree diagram.